In the early spring of 1943, a German U-boat commander named Hans Joachim Rathke raised his periscope somewhere in the black North Atlantic and watched a convoy pass. Ship after ship moved through his crosshairs. He noted the tonnage. He radioed his position to the wolf pack. And then something unsettled him. The convoys never seemed to end. Every ship his boat sank was replaced by two more. Every convoy they tore apart was followed by another one, larger, better escorted, arriving from the west as if from an assembly line that never stopped running. Because it didn't. 3,000 miles away, in Richmond, California, a crane was lifting a prefabricated steel section the size of a 2-story house and lowering it onto a growing hull. Somewhere in Iowa, a steel mill was cutting plates to tolerances that matched a specification sheet mailed from a California shipyard. Somewhere in New Orleans, a woman named Gladys was learning to lay a weld bead in 4 hours that would have taken a trained shipwright 4 days to learn in peacetime. This was not a miracle. This was a system, and the system was winning the war. When the ocean was losing. To understand what happened in the spring of 1943, you have to go back 3 years, to the days when Germany was winning the war at sea. When France fell in June 1940, the Atlantic coastline of France, Lorient, Brest, Saint-Nazaire, La Rochelle, fell with it. For Admiral Karl Donitz, commander of Germany's submarine fleet, this was the moment he had been building towards since 1936. The U-boats could now operate from French ports, cutting hundreds of miles off every patrol and reaching deep into the Atlantic, where no British escort could follow. Donitz had served as a U-boat commander in the First World War. He understood submarines the way a surgeon understands a scalpel, and he understood Britain. Britain was an island. Britain could not feed itself, fuel itself, or arm itself without the sea. If you cut the sea lanes, you cut Britain's throat. Not with battleships, not with invasions, with submarines. His tactic was called Rudeltaktik, wolf pack tactics. One U-boat would shadow a convoy on the surface, radioing its position. Others would converge during the night. Then they attacked together, in darkness, when the escorts were blind and the merchant ships were silhouetted against the horizon. The results were catastrophic for the Allies. The period from the summer of 1940 through the end of 1941 became known in the German Navy as die glückliche Zeit, the happy time. U-boat commanders like Otto Kretschmer, Günter Prien, and Joachim Schepke became national heroes in Germany. Their photographs appeared on the front pages of newspapers. Hitler decorated them personally. Between them, the top aces had each sunk hundreds of thousands of tons of shipping. When America entered the war in December 1941, Donitz launched Operation Drumbeat, 5 U-boats sent to the undefended American East Coast. American cities still blazed with peacetime lights. Merchant ships were silhouetted against the glow of Miami and New York like targets in a shooting gallery. In the first month, 5 submarines sank 25 ships. By March 1943, Donitz's fleet sank 120 merchant ships in a single month, over 600,000 tons. The British Admiralty recorded in an official assessment that Germany had never come so close to severing communication between the New World and the Old. But that same March, something was happening 3,000 miles away that Donitz had not fully calculated. The man who had never built a ship Henry J. Kaiser had spent his career building things that didn't float. Roads, bridges, dams. He had built Hoover Dam. He had built Bonneville Dam. He had built the biggest civil engineering projects in American history. But ships? He had never touched ships. In 1940, the United States Maritime Commission needed someone who could build cargo vessels at a speed the industry had never attempted. The established shipyards moved slowly. A standard cargo vessel took 240 to 300 days to complete. At that rate, the Germans would win before the hulls hit the water. Kaiser raised his hand.
The Maritime Commission hesitated. This man had no background in shipbuilding. His credentials were in earth and concrete, not steel and sea. Kaiser's response was recorded by several people who were in the room. He looked at the commission and said, "A ship is just a building that floats." That statement was either the comment of a fool or a genius. It turned out to be genius.
Kaiser brought in the industrial logic of the American automobile industry. He had watched Henry Ford's Highland Park assembly line transform car production. He understood that the key insight of mass production was not speed, it was the elimination of judgment at the point of assembly. When a worker on a Ford line bolted a wheel to an axle, he did not judge whether the wheel fit. It fit because the tolerances had been controlled upstream, at the foundry and the machine shop. The worker's job was to bolt, not to judge, not to file, not to fit, just to bolt. Kaiser applied this principle to ships. He divided each Liberty ship hull into 250 prefabricated sections. Each section was built at an inland factory in Denver, in Seattle, in Pittsburgh, in Des Moines, places that had never seen salt water. The sections were built to tight tolerances against a master specification. Then they were loaded onto flat cars and railed to Richmond, California, where 4 Kaiser shipyards sat on San Francisco Bay. At Richmond, cranes picked up the sections and set them in place. Welders fused them together. Inspectors signed off on each joint. And a ship that had been a collection of inland steel sections 2 weeks earlier floated off the ways into the bay. He also abandoned the rivet entirely.
Traditional shipbuilding was riveted construction. 2 workers per rivet, one to throw, one to catch and set. Skilled, slow, and irreplaceable. Kaiser replaced riveting with welding. Welding could be done by one person. Welding could be taught in weeks. And welding, unlike riveting, could be done by people who had never worked in a shipyard before. This decision changed everything. The women who welded the war. On December 7th, 1941, the attack on Pearl Harbor sent millions of American men toward recruiting offices. Factory floors emptied overnight. Kaiser faced a production crisis that no manager's handbook had addressed. He had the method, the steel, and the contracts. He didn't have the workers. The answer was in the neighborhoods surrounding his yards. Kaiser was not typical among American industrialists of his era. In 1942, when union halls were composed overwhelmingly of white male workers, Kaiser bypassed the unions entirely and recruited directly from employment offices, from church bulletins, from newspaper advertisements that addressed, for the first time in American industrial history, women and black workers as the primary audience. His advertisements read, "If you can use the tools at home, you can learn to use the tools in the yard." Richmond, California exploded. A city of 24,000 became a city of 100,000 in 3 years, as workers arrived from Alabama, Texas, Oklahoma, and Louisiana. 1/3 of Kaiser's 90,000 shipyard workers were women.
In February 1943, women made up nearly 41% of all laborers at the Richmond yards and more than 37% of the boilermakers. Gladys Theus became known as the fastest welder at Kaiser Richmond Shipyard No. 1 in 1944. Louise Cox had sent her brother to the Navy and taken his place on the production line. She became the first female welder trainee at Shipyard No. 2 and spent her off hours designing improved safety clothing for women in the yards. Eastine Counter worked as a scaler on the hull of the SS George Washington Carver in 1943, grinding old paint and rust off steel plates in the hull's dark interior, work that paid less and required more physical endurance than almost any other job in the yard. But these workers understood something precise about what they were doing. The welds they laid and the bolts they drove would carry food, fuel, ammunition, and tank parts across an ocean where German submarines were hunting. The ships they built would deliver those supplies to men who might be their husbands, their brothers, their sons. The quality of their work was not an abstraction. The numbers confirmed it. Between September 1942 and June 1943, the labor hours required to build one Liberty ship fell from 523,000 to 349,000, a 33% efficiency gain in 9 months. Not because of new technology, because of practice, training, and a workforce that knew exactly why the work mattered. The mathematics of drowning? Donitz ran his war on arithmetic. Every week, his staff compiled 2 numbers: how many tons of Allied shipping had been sunk, and how many tons of new shipping had been launched. If the first number exceeded the second, Germany was winning. The supply line was contracting. Britain was slowly starving. The math was simple and brutal. In 1941, the math favored Germany. In 1942, the question was in balance. But by 1943, something had shifted in the numbers that no amount of tactical brilliance could correct. In 1943, 3 Liberty ships were completed every single day. Not every week, every day. By the end of that year, American yards were delivering more than 140 new cargo ships per month. Donitz's submarines, even at their peak efficiency, had never managed to sink more than 96 Allied ships in a single month, a figure achieved only once in March 1943. And even that record came at a cost that the German Navy could not sustain. Each U-boat carried a crew of around 50 men. Each crew required over a year to train to full operational readiness. Experienced U-boat commanders, men who knew the sound of a distant destroyer engine, who could calculate an attack angle in seconds, who had learned through dozens of patrols how to survive, were irreplaceable assets. When they went down with their boats, they took years of accumulated knowledge with them. The invisible weapon. A hunter operates in darkness. This was the first principle of wolf-pack tactics. U-boats attacked on the surface at night, running fast on diesel engines, invisible to the slow escort vessels that moved in a convoy's shadow. By the time a destroyer located a submarine, the boat had dived and was gone. But from late 1942 onward, the darkness had changed. The Allies had deployed a new type of radar that operated on centimetric wavelengths, wavelengths so short that the conning tower of a surfaced U-boat, a steel cylinder barely 6 feet in diameter, showed up on the screen from miles away. In rain, in fog, in the total blackness of an Atlantic night. German U-boats carried radar detection equipment that warned when they were being painted by enemy radar. But the new Allied radar operated on frequencies that the German detectors couldn't hear. The first warning a U-boat crew received that they had been located was the sound of an aircraft engine overhead. Or no warning at all. The depth charges simply arrived. U-boat commanders began filing reports that described attacks from nowhere. No aircraft seen, no destroyer sound contact, just explosions from the darkness. In their war diaries, some speculated that the British had developed a magnetic detection system. Others believed there were informants in the German fleet. The real explanation was a small antenna mounted under the nose of a Liberator bomber flying out of Iceland. The combination was decisive. Radar that found them. Aircraft that could reach the mid-Atlantic gap that had previously been unreachable. Escort carriers that brought air cover to the convoys themselves. And behind it all, a production system that was replacing every ship lost faster than any submarine fleet could sink them. Black May. The reckoning arrived in May 1943. Dönitz assembled the largest concentration of U-boats he had ever deployed. Over 160 submarines in the North Atlantic, attacking 5 convoys simultaneously. It was the maximum effort of the German submarine war. Every card played at once. What happened next was catastrophic for Germany. Unknown to Dönitz, British cryptanalysts at Bletchley Park had broken the Enigma cipher codes that the German Navy used to coordinate U-boat operations. Every time a U-boat radioed its position to the Wolfpack control, British intelligence read the message. Every convoy diversion, every change of routing, every patrol zone had been directed partly by intelligence the Germans didn't know was compromised. And every radio transmission also gave away the U-boat's position to aircraft carrying centimetric radar. In May 1943, Germany lost 41 submarines. In the previous month, losses had been 15. 41 submarines meant roughly 2,000 trained men. It meant dozens of experienced commanders who could never be replaced. It meant the destruction of the institutional knowledge that had made the Wolfpack system work. In exchange, the U-boats had sunk 96,000 tons of Allied shipping. That same month, American shipyards launched over 140 new vessels. The arithmetic had reversed completely and permanently. On May 24, 1943, Grand Admiral Dönitz withdrew the overwhelming majority of his submarines from the North Atlantic. In the German Naval War Diary, the entry recording this decision concluded with a sentence that historians have quoted for 8 decades. "We are fighting a stronger enemy. We have become the hunted, not the hunters." The Battle of the Atlantic was effectively over. Not because the U-boats lacked courage, not because German submarine technology was inferior, because America was building faster than Germany could sink, inside a Liberty ship. To understand what the German commanders were calculating against, you need to picture what a Liberty ship actually was. It was 441 feet long. It could carry 10,000 tons of cargo, 440 light tanks, or 2,840 jeeps, or thousands of tons of artillery shells, fuel, food, and medical supplies. Its triple expansion steam engine pushed it through the water at 11 knots. Slow, unglamorous. President Roosevelt himself called them ugly ducklings. They carried a 3-inch gun forward, a 4-inch gun aft, and several anti-aircraft mounts. Against a submerged submarine, they were defenseless, dependent entirely on their escorts. But against a surfaced U-boat, the condition under which Wolfpack attacks were conducted, they could fight back. And now that surfaced U-boats attracted aircraft radar from 40 miles away, U-boats were spending more time submerged, where they were slow, limited in range, and far less dangerous.
The ship itself was not the innovation. The ship was an adaptation of a British design that dated to 1879. Solid, proven, and entirely unremarkable. What was revolutionary was the method. Kaiser's prefabrication system meant that every Liberty ship hull was divided into sections that had been built to matched tolerances at inland factories and assembled at the waterfront like an industrial jigsaw puzzle. The cranes picked up a stern section built in Des Moines, a midship section built in Portland, an engine room casing built in Pittsburgh, and set them in place. Welders joined them. Inspectors certified every joint. The ship went in the water. By 1944, the Richmond yards were completing a Liberty ship every 42 days on average. That was the average. The record set by the SS Robert E. Peary in November 1942 was 4 days, 15 hours, and 29 minutes from keel laying to launch. The press called it a publicity stunt. Kaiser called it a proof of concept. The German engineers who read the wire reports in Hamburg and Bremen called it a method they would have to copy. They could not copy it. They didn't have the system behind it. When Liberty ships cracked. There is a part of this story that is told less often because it complicates the clean narrative. Some Liberty ships broke in half. The welded construction that made Kaiser's production system possible also created a vulnerability that riveted ships did not share. In the extreme cold of North Atlantic and Arctic waters, the specific steel alloy used in early Liberty ship hulls could become brittle. Under the stress of a heavy sea, hairline cracks could propagate across a weld joint and through a hull plate with no warning. In several cases, Liberty ships broke completely in two while underway, some in calm weather with no enemy action involved. The engineers called it brittle fracture. The American response was systematic. The steel specification was changed. Hull plate thicknesses were increased at vulnerable connection points. Welding standards were tightened, and inspectors were given authority to reject work that didn't meet the new criteria. Crack arresters, small slotted plates designed to stop a propagating fracture before it could cross the hull, were retrofitted to ships already in service and built into every ship launched afterward. This is the same thing that Germany failed to do with the Type 21 U-boat. When the prefabricated hull sections didn't fit together at final assembly, German subcontractors improvised their own solutions. There was no central tolerance authority, no William Knudsen walking into a factory to throw out parts that failed the gauge. Each yard decided for itself what was good enough, and the result was submarines that couldn't go to sea. In war, the side that learns from its mistakes faster than the enemy wins. America learned from its broken ships and built better ones. Germany built 119 Type 21s and sent one on a war patrol. The final arithmetic. When the war in Europe ended on May 8, 1945, the numbers told the complete story. The United States had delivered 2,710 Liberty ships during the war. Those ships carried 2/3 of all cargo transported from America to the overseas fronts. They carried the Sherman tanks that rolled through France. They carried the aviation fuel that filled the bombers over Germany. They carried the food that kept Britain alive through 5 years of siege. Germany had commissioned 1,155 U-boats and sent 757 on operational war patrols. Of those 757, more than 500 were lost, sunk by aircraft, by surface escorts, by mines, by accident. Of the approximately 40,000 men who served in U-boats during the war, 27,491 were killed, a loss rate of nearly 69%. No other branch of any military in the Second World War suffered proportional casualties on that scale. Against those losses, the U-boats had sunk 2,779 Allied merchant ships, totaling 14.5 million tons. They had come closer to winning the war at sea than any submarine force in history. In the early years, they had nearly succeeded. But by 1943, they were sinking less tonnage per month than American yards were launching, and that gap widened every month until the end. Donitz had built a weapon capable of severing the Atlantic lifeline. Kaiser had built a machine capable of replacing every link in that lifeline faster than Donitz could cut it. What the periscope couldn't show. In early 1944, a German engineer attached to the Naval Construction Program compiled an analysis for the Kriegsmarine. He had studied the American production figures the Germans were able to partially reconstruct from neutral shipping reports and captured documents. His conclusion, submitted to Naval Headquarters in Berlin, was direct. He wrote that the United States was not building ships. It was operating a production process that treated ships the way other industries treated consumer goods. The analysis noted that American yards had industrialized every step of construction that could be standardized, trained unskilled workers to perform those steps without judgment or adjustment, and built quality control into the process upstream at the inland factories rather than at final assembly. The result was that each individual ship was not the product of skilled craftsmen. It was the output of a system. The engineer's conclusion was that Germany could not compete with a system using the tools and traditions available to German industry. He was right. Germany had brilliant engineers. Germany had the firms that had given the world Krupp, Daimler, Zeiss, and Bosch. German precision manufacturing was the envy of the world. But German industrial culture still placed the skilled craftsman, the Facharbeiter, at the center of production. A German part was finished by a man with a file and a micrometer who took pride in making it fit. An American part was finished by a gauge that said pass or fail, with no room for interpretation. That difference between fitting and gauging, between judgment and standard, had decided the war at sea before the first torpedo was ever fired in 1939. It had been decided in the American armories of the 19th century, in Henry Ford's moving assembly line at Highland Park, in the principle that William Knudsen had carried from General Motors to the War Production Board. A part that doesn't pass the gauge is thrown out, not adjusted, not filed, not persuaded into position. Thrown out. What stayed below? When a German submarine raised its periscope in the North Atlantic in the spring of 1943 and watched a convoy pass, the commander saw cargo ships. He saw tonnage. He saw targets. What he couldn't see was the production system behind each ship. He couldn't see the steel mill in Pennsylvania that had rolled the plate to a specification that matched the steel mill in Ohio that had rolled the plate for the next ship, and the one after that, and the 50 after that. He couldn't see the jig in Des Moines that had positioned the frame to a tolerance of a 32nd of an inch, so that when the section arrived in Richmond, it dropped onto its mating section without hand fitting. He couldn't see the women at Kaiser Shipyard No. 2, who had won the right to join the Boilermakers Union in September 1942, and were now the most productive welding workforce on the Pacific coast. He saw a slow, ugly cargo ship making 11 knots in a convoy. He didn't see the system that had built it in 2 weeks and would build 3 more by Tuesday.
Admiral Donitz wrote in his memoirs that Germany's defeat in the Atlantic came from an insufficient number of submarines. He was wrong. Germany built over 1,000 submarines. What Germany never built was the production system that could keep the boats at sea faster than the Allies could sink them, replace the crews faster than the Atlantic could kill them, and field new technology faster than the enemy could develop countermeasures. America had been building that system for 150 years. In Springfield and Harper's Ferry, in Detroit and River Rouge, in Richmond, California, where on the evening of November 8, 1942, a woman named Louise Cox picked up a welding torch for the first time and fused two pieces of steel together. She did it wrong. The inspector made her grind it out and do it again. She did it right the second time. That was the difference. Not genius, not heroism. The willingness to throw out the bad work and do it again until it passed the gauge. Germany had the better submarine. America had the better shipyard. The shipyard won.